So you're going to have to be my eyes on that. Okay, so everything that you have learned in Chapter 4 and everything that you have learned in Chapter 5 is going to basically come all together, and it all comes down to being able to solve equations. Okay, so we are solving specifically trig equations. Okay, so let's start with writing one. So let's say I have 2 sines of x minus 1 is equal to 0. Okay, so you are using your algebra techniques to isolate the trig function. Okay, so how would you solve for this sine of x? You would add 1 and divide by 2. Perfect. So add 1. So I have 2 sines of x equaling 1 divided by 2. The sine of x is equal to 1/2. Okay. So at this point, this is where we grab our unit circle. Okay. So you remember on the unit circle that the sine is your which values? Your y values. Okay. And your cosine is your x values, and your tangent is your y over x. And we can keep going, and we could even say, now let's never go that other side. We'll just keep everything in terms of sine, cosine, and tangent. Okay, we can always do that. Okay, so if we've got a sine equaling 1/2, you should be looking at your unit circle and deciding where on the unit circle is the y value of 1/2. Okay, so we're looking for angles. There should be 2. What's that? Okay, give me radian degrees. Good question. Let's do radians. So pi over 6. And where's the other one? There's another one. There you go. 5 pi over 6. You see both of them? Okay. Now, basically what this means is this is 2 solutions. But there actually happens to be a whole lot of solutions. And I want to show you why. Okay, I'm going to graph this equation on the calculator and show you what we're looking for. Okay, you guys know that I can solve any equation by just graphing it. If I set it equal to 0, I'm looking for specifically where it does what? Where it crosses the x-axis. Okay, so you can solve any equation using this method. Okay, so if I type in 2 sines of x minus 1. Now before I hit enter, I'm going to go ahead and make sure my mode is in what should it be in? Radians. Okay, so I'm in radians. And I'm going to go ahead and just hit graph and see what I can see. Okay, so you know, because you've done graphing, that if I'm graphing a sine function, it looks like a wave. How many times does this function cross the x-axis? Okay, yes, 7 times in this window. But what if I zoom out? It crosses a lot of times, infinite number of times. Okay, so how are we going to say, I only got 2 answers, but I know that there's going to be more than just 2 answers? Okay, so what we're going to do is we're going to say, well, do you notice that it's kind of hitting like at the same spot of that revolution? Okay, so like, see how it's kind of like at the top of that hump every time? So the first one is like at pi over 6. The next one's at 5 pi over 6. And it keeps continuing. Okay, so this is directly related to the period of the function. You remember how to find period? Nice. So if you don't remember that, period is 2 pi over b. Okay, so what I'm going to do is I'm going to say plus or minus, there's going to be an infinite number of revolutions, and it's going to happen every 2 pi over b. What's my b in this case? Do you guys remember how to find the b? It's just a 1, yeah. It's just the number that's directly in front of the x. So in this case, it's a 1. So what is my period on this function? 2 pi. Okay. So we're going to hit that same spot every 2 pi units. So that's your solution. That is this whole section. Yes. Okay, it does get harder because sometimes you have to manipulate the equation with your identities to make it easier. Okay, it's usually not as complicated as our assignment was today or yesterday. Usually, 99% of the time. Every once in a while it is. Let's do another one. So let's say we have 3 tangents squared of x minus 1. Now this is an interesting scenario. Okay, so again, I'm solving for the tangent, so what are my steps? Okay, so add 1, divide by 3. Can I do those steps really fast? Is it okay? Good. So I have tangent squared is 1/3, and then I have a squared, so I have to square root it. Okay, so we get a tangent is equal to, let's see, if we square root 1/3, that would be 1 over the square root of 3, which I can't leave. It becomes, I'm going to leave it. Because remember, this isn't my answer. This is the part where I have to use the unit circle. Okay, what also do I need in front of this? Because I took a square root. Very good, a plus or minus. Okay, so now we grab our unit circle. Are you ready? This is the hard one because it's a tangent. Remember, tangent is y over the x. Okay, so somehow the y over the x reduced to 1 over the square root of 3. So what is the ordered pair that would create that scenario? What does the y value have to be and what does the x value have to be?
-1/2.
Okay, very nice. So if we're doing y over x, and that has to equal 1 over the square root of 3, I know that the y value has to be 1/2. Whoops, my y value. I didn't write that correctly. The y value has to be, oh my gosh, come on. 1/2. And the x has to be the square root of 3 over 2. Okay? And that's something that we talked about a while ago, and I said, put this on your unit circle so you have this forever. And I hope that you did, because here it comes again. Okay? So, there's 4 places, because remember there's a plus or minus in front of this. This is going to have 4 answers. 4 places where we have the x is the square root of 3, and the y is 1/2. We're looking at plus or minus versions of all of that. What are my 4 places on the unit circle? 5 over 6 is 1. 5 pi over 6 is 2. 7 pi over 6. And 11 pi over 6. Okay, and then I have to say, oh yeah, because this is technically a tangent function that goes on, it's like a dance party forever. So plus or minus my period. The negative radians. Oh yeah, right. You can just use your regular, because we're going in both directions. And when we say the plus or minus period part, that'll take care of that. Okay. Okay, so I would say plus or minus n period. Period for tangent. Okay, so here's something we have to talk about tangent. Period for tangent. And cotangent. Okay, so back when we were doing periods, I always said period is 2 pi over b. Well, I kind of lied to you. Okay, I totally lied to you. I totally lied to you. And the reason why is because it made graphing really easy. Okay, so now I have to like come clean and tell you that I lied to you, so sorry about that. But now you can use the fact that the tangent and cotangent are actually, pi over b. Okay, and here's why. I'll tell you why I lied. Okay, so remember how when we were drawing a period and we were drawing one period of our tangent functions, how many John Travoltas did you draw? Exactly 2. Okay, so by definition, a period is like when the function becomes itself. Like, how can I say that? Duplicates itself. Do you see what I'm saying? So like the sine function duplicated every full revolution, but the tangent and cotangent with the John Travoltas, like made a John Travolta and then a second one, which is exactly the same as the first part. Because of the y over the x thing. So anyways, that's why that makes sense anyway. So there's your period. So write that down and highlight it next to your unit circle so you remember this. Well, it's technically one John Travolta. Technically one. Exactly. Technically. I lied to you before. It's not two. It's actually one. Okay, so what's my period on this particular case? Pi. Good. Pi. Okay, does anybody remember what else I've told you? Because this answer isn't entirely right. Let's see if it resurfaces. Yes, very good. Okay, so remember when we were doing the arc stuff? Arctan, arcsine, and I said, okay, we're finding angles, but the angles can only exist in certain quadrants. The sine and the tangent can only exist in the first and the fourth quadrant, remember that? And the cosine can only exist in the first and the second. That comes back. I have to use that scenario. Okay, so tangent can only exist in the first and the fourth, so that means which two answers are not right? Oh, I missed my pi on this, sorry. So which ones? Yeah. Because they can only exist in the first and the fourth quadrants. And it's okay if we use the positive versions because of the idea that this is going in infinite directions. That'll be okay.
For the first problem, we did the sine function.
Uh-huh.
And sine can only answers for sine.
Right.
But one of the answers is 5 times 6.
Okay. So we should cross it out, right? Nice, good. You're ahead of me. Good catch, good job. Okay, let's try another one. See if we can add it all together this time. This is going to be like all of it. It says the cotangent of x times, the cosine squared of x is equal to 2 cotangents of x. Okay, so this is pretty icky. And remember, the whole goal here is for me to isolate it and turn it into one trig function. So that means I'm going to have to play with my identities a little bit. Who's got an idea? So the first thing that I want to do, I will tell you, is that you want to set this equal to 0 and get all of the trig stuff on the same side so that you can play with it the same way you did in the last section. Okay, so if I pull everything to the same side, I'm going to start by just subtracting the 2 cotangents to the left. Okay, so cotangent of x times cosine squared minus 2 cotangents of x. Okay. So now we're going to condense this into one trig function. What do you see? Okay, they both have a cotangent in it, so what can I do? Trying to think if that would be good. I think the easiest way to do this one is to just factor it. Okay, so you know how like when we were factoring before and we had it set equal to 0, you can just set each of the quantities equal to 0 and solve it as 2 separate equations. Let's do that because this is easily factorable because we can pull out a greatest common factor. What's my greatest common factor? Cotangent. Okay, so if I pull out a cotangent, the first term is still going to have a cosine left. And then what's going to be left of the second term? 2. 2 times cotangent, right? 2. Okay. So now at this point, this is the whole idea of factoring and setting it equal to 0. I'm going to set both of the quantities equal to 0 because both of these two quantities are isolated with one trig function in it. Okay, so we can say that cotangent of x is equal to 0 and the cosine squared x minus 2 is equal to 0. We can work with those two separately. Okay. All right, so let's do the cotangent of x. I think that one's pretty simple. Okay, so do you remember what cotangent is? Remember that's the reciprocal of tangent. It's what over what? It's x over y. So we need the unit circle for the x over the y to equal 0. So if the x over the y is equal to 0, we know specifically one of the variables is what? One of them is 0. Which one is 0? The x. Okay, so where on your unit circle is the x value 0? And remember, pi over 3 and pi over 2. Okay, good. I'm going to say pi over 2 and then pi over 3 because that's just smaller and big. Okay, and then I'm going to add in my pi over 2 and 3 pi over 2. What?
Oh, I thought you said pi over 3. So.
Oh, I did?
Yeah.
Sorry, my bad. Sometimes my mouth says weird things. But I wrote it right, so that's important. Okay, so plus my n period. So what's my period on cotangent? On this cotangent? Pi, good. So n pi. N pi, okay, good. So we got part of our solutions. Okay, so now we're going to solve the cosine squared minus 2. So what do I do here? So add 2. And then what? Square root 2. So I have the cosine of x is equal to a plus or minus square root of 2. That's interesting. So cosine is which variable on our unit circle? The x. So is there a place on your unit circle where the x value is just a square root of 2 or a negative square root of 2? There's square root of 2 over 2, but that's not the same. So can I solve that particular equation? No. Okay, so this one is a no solution on this, which happens. So my answer is just the one that I got from the cotangent equation. Yep. No, not always. It's possible for all of the scenarios to happen. Both might produce a no solution, one might produce a no, or they might both produce a solution. So it's kind of a rare scenario where you're finding a lot of answers instead of just one, like we're so used to just finding, oh, x is 5, done. Should I do one more? Do you guys want me to start this assignment with you? Okay. Let's do page 331. We're going to do 2 through 38 evens. And let's just go ahead and start by doing this together. We'll see how far we get. What did you do first for this question? Subtract 5, so we can say that we got 2 is equal to the secant squared of x. Okay, then what? Let's not get your confused on that step. That was the
You
easy one.
subtracted 5, so it should all be on the same
No,
side.
subtracted 3.
No, she said it.
Because there's only one trig function, so you solve for the secant.
Yes, you said it. Okay.
Damn.
Yeah.
I'm having a bad talking day. Okay, so square root. Sorry, Skylar. So then we get secant. Okay, now what I can do when I'm left with a reciprocal trig piece is, in my opinion, it is easier to work with a sine and a cosine, and usually a tangent. Tangent's not as hard, but I'm going to reciprocate this, and then it'll be easier to work with. So the reciprocal of secant is cosine. So the cosine of x is equal to the reciprocal of the square root of 2. What's the reciprocal of the square root of 2? Ooh, nice. The square root of 2 over 2. Everybody okay with that? Because you have 1 over the square root of 2, and you can't leave a square root in the bottom, so you multiply by the square root of 2 over 2. I just reciprocated it. Reciprocal of secant. Okay, so now on your unit circle, you're looking for where the x value is the square root of 2 over 2, and you need a positive one and a negative one. So you should get 2 answers.
Power 1, 3, 5.
Pi over 4 and 3 pi over 4. Okay, and then we're going to say plus or minus n, what's my period? 2 pi.
So the period is different with tension.
Right, and that's it. That's the only one I lied to you about. Where do you get the period from? 2 pi over the b, unless it's tangent
Yeah,
or
so where's
cotangent.
that at?
The b is the number directly in front of the x,
Of which one though?
the cosine. The cosine of x. Yes.
So if you let us know that, like how our graphs turn out, right?
Yeah. Right, I know, right? It's because, so, okay. Technically, the definition, I'm gonna pause this. So we have 4 tangents of x minus 7 is equal to 3 tangents of x minus 6. Okay, so the good news on this one is that we are only dealing with a tangent. We need to get all the tangents on the same side and set it equal to everything else. So what would you do? Subtract 3 tangents. Good. Would you mind if I added a 7 at the same time? That bother you at all? So I end up with, that would. Sorry, I never know if you're... So I get a tangent of x is equal to 1. Anybody else get that? Awesome. Okay, so that's a nice one. I'm okay with that. Because tangent is y over x. So for y over x to equal 1, what do we know about the y and the x? They're the same. Okay, so they're both positive or they're both negative. So where's my solution? Did anybody say pi over 4 yet?
Yeah.
Okay, I didn't hear anybody say that. I was like, that seemed like the easy one. Did I miss that? And then what?
It'd be 5 pi over 4.
5 pi over 4. Are you sure about that?
It can't be
No, it can't. Because it's first and fourth, right? Isn't 5 pi over 4 in the fourth quadrant?
It's the only one that has some negative.
5 over 4?
Oh yeah, so then we're done, right? It's just pi over 4.
The 7 pi over 4.
Yeah, right, it would be a negative 1. Okay, so it's just pi over 4, and then we would say plus or minus n, and then what's the period on the tangent? Pi, good. There we go. Number 6. So we have 2 minus 10 secants. Okay, so this is kind of similar in number 4 as far as our first step. Yes, that's a 9. Looks like a curly 9. It has a hat on. Okay, so if I get my secants on the same side, can I go ahead and add 10 secants? and then subtract 4. So I get negative 2 is equal to a secant of x. Okay, so I'm going to do the same exact thing that I did on question number 2 because I'm dealing with the secant. So what is the reciprocal of the secant? Cosine. So I'm going to have cosine, and then what's the reciprocal of negative 2? Negative 1/2. Good. Okay, so cosine is x, so where in your unit circle is the x? A negative 1/2. 2 pi over 3. Okay, and then plus or minus n, what's my period? 2 pi again, yeah. Let's see, 8. 11 is equal to 3 cosecant squared plus 7. Okay, what would you do for this one? Subtract 7, divide by 3, square root. Perfect. Okay, so we get 3 is equal to 3 cosecant squared, divide by 3. So we get 1 is equal to the cosecant squared. 4. Oh. Shoot. Sorry, guys. You're right. 4. I liked 3 better, so that worked nicer. So that makes 4/3. Boo. Okay, so then I square root it. So that gives me 2 over the square root of 3, which I'm going to leave it like that because I have a cosecant, and I'm just going to flip it. So what's the reciprocal of cosecant? Sine. So we got sine of x is equal to square root of 3 over 2. And that's on my unit circle because that's your y. So where is your y? A positive or a negative square root of 3 over 2. Pi over 3. And then it can't be 2 pi over 3 because that's second quadrant. So what about, because it's sine. Sine only exists in first and fourth. So what's the fourth quadrant one? 5 pi over 3? So then plus or minus n, and then what's our period? 2 pi. Sure. How would you guys feel about me skipping a couple and going to ones that are harder? Like, I feel like number 12 is same story, and number 10 is what we've been doing. Let's do one that's like harder. Like, let's go to 14 or something where it gets a little tougher. Is that all right with you guys? Do you feel like you're getting those first few questions? Okay, so let's go to a harder problem. Let's try 14. So 14 is negative 2 sines of x equals a negative sine of x cosine of x. Okay, so this is kind of similar, at least the first step, to the third example that I did. What's my first step? Good. Okay, so I either want to pull everything to the right-hand side or pull everything to the left, but I have to add, either way. So you said add 2 sines. That's fine with me. So add 2 sines. Whoops. Ooh. Okay, so then what would you do? Good, very good. Factor out a sine. Okay, I could technically pull out a negative, Do you guys want to pull a negative or leave it inside? I don't think it'll matter either way. Leave it in? Okay, so we're going to pull out a sine of x. So we'll be left with a negative cosine plus 2. Okay, so since I factored, now I'm going to set each of the quantities equal to 0. So I'm going to have a sine of x equaling 0. Ooh, excuse me. And a negative cosine of x plus 2 equal to 0. Okay, so the left one is easier. Okay, so it's already solved. I'm looking at my y. So where is the y value 0? At 0, or you could say 2 pi. Anybody have a preference on that? 0 or 2 pi? 2 pi feels better? Doesn't matter because it's going to eat that up in your plus or minus part. So n, and then what's your period on the sine? 2 pi. We should do one where the period is different. Haven't seen any of those. Okay, so on the other one, I'm going to add a cosine. Okay, so now it's solved. So is there an x value that has a 2 on it? No. Okay, so that's a no solution. That one's not possible. So 14 just has the 1 answer. Oh, I missed something. Did anybody read the directions? Minor details of those directions. So at the top of it, it says, solve the solution of the equation on the interval between 0 and 2 pi. So if we're only looking at 0 and 2 pi, how does that affect my answer here? Exactly, good. I don't have to do this plus or minus part. Okay, because I'm only going to exist between 0 and 2 pi. So only, yeah, exactly. And it says 0 and 2 pi. I mean, if you wanted to be really exact, you could say 0 and 2 pi on this one. Let's just be exact, because that's how we are. We're exact. Even though they're the same exact spot. Okay. What about, 16. Let's try 16. So we get cosecant squared minus cosecant plus 9 is equal to 11. Okay, so I immediately notice that there's something that is squared. So what do you think I will have to do for this question? Factor it. Very good. Okay, so I will factor this using my easy method. The first thing I have to do, though, is get rid of that 11. It has to be set equal to 0 before I can factor. So what's my first step? Subtract 11. So that gives me, what, negative 2? Double check my math there, because I'm not good at subtracting today. Okay, so then I can factor what two numbers multiply to negative 2 and add to negative 1. Negative 2 and positive 1, because I have a quadratic, technically, of something that is squared. So I'm going to factor it. Okay, so once I've factored it, I'm going to set each piece equal to 0. Okay. So then I have, let's see, I add 2, I have cosecant of x is equal to 2. So I'm going to reciprocate that. The reciprocal of cosecant is sine. So my sine is equal to 1/2. Good. Okay, so where on the unit circle is the y value 1/2? 5/6. Good. Plus or minus, no, wait. Nope, no plus or minus, because I just talked about that. Okay, and then on my second equation, I'm going to subtract 1. So cosecant equals negative 1. You can flip it, so the sine also is negative 1. So where is the y negative 1? 3 pi over 2. Nice. Okay. Ooh, 17. Okay, so do I need to do number 18 with you? 18 is also quadratic. That also requires factoring. Do I need to do that one? Do you guys feel like you got that? Okay, maybe we should skip to number 22 where they have different trig functions. Let's do that. Let's skip to 22. So this one also has the same directions about only between 0 and 2 pi, so remember that, because I'll probably forget. The secant of x is equal to the tangent plus 1. Okay, so what do you guys think?
Tangent of x plus 1 is equal to secant squared.
That would be true if it was tangent squared plus 1.
Right.
Good idea, though. I like that better. That would have been easier. Okay, so we can say that secant is 1 over cosine, and tangent is sine over cosine, and 1 is, ooh, I like it, cosine over cosine. What can I also do right now? When you're solving an equation and all the denominators are the same. Yeah. Ooh, that was nice. I think. Yeah, you're right. Should we try that? Because we got to get rid of it. We square everything. But if we square both sides, you have to square it as, you'd have to like square it as a quantity. Like this. I think I'm okay with that. Hold on, I have to think again. Because the middle term would be, because you'd have sine squared plus 2 sine cosines plus cosine squared. And the sine squared and cosine squared would make 1, but you still have 2 sine cosine.
Right.
Write it all out.
Yeah.
The two ends. A sine and a cosine. Yeah. Oh, that's okay. Hold on, I think I got this. Let's do it. Okay, we got 1 is equal to sine squared plus 2 sine cosine plus cosine squared. Okay, so we just said that if you add sine squared and cosine, that makes 1. Okay, so watch what happens here.
Wait, what?
Because sine squared plus cosine is the Pythagorean identity, it's equal to 1.
But it's sine squared.
Yep, which is exactly what I have. They're just not next to each other. And now if I subtract 1, now I'm set equal to 0, and I'm okay with that. Now I have 0 is equal to 2 sine of x times the cosine of x. And this is kind of like the factored form. Either the sine of x is 0 or the cosine of x is 0. We can ignore the 2 because the 2 is, well, I mean, you could just divide by 2, right? Yeah. So we can have the sine of x is equal to 0 and the cosine of x is equal to 0. So, where is the sine equal to 0? or the y, sorry, the y equal to 0. At where? 2 pi, yeah, 2 pi. Or you could technically say 0. And then where is the x equal to 0? Pi over 2. This one has an extraneous solution. Do you guys remember what an extraneous solution is? One of our solutions doesn't work. So this always happens when you go back and something is in the denominator. So it's like, is there ever a value that makes the denominator 0? Okay, which of these values makes a cosine 0? So like think about on your unit circle, where is the x 0? Pi over 2. So pi over 2 is your extraneous solution because the cosine of pi over 2 is 0. Does that make sense? That makes the function undefined at that point. That's tricky. That's like bringing all of your algebraic skills like all together. Like everything you've learned. It's kind of intense, right? Do you guys want to do one more? I think we have time for one more. 24? Might as well. So we got cosecant of x plus cotangent of x. Okay, what do you guys think about this one? Okay. Perfect, good. So cosecant is 1 over sine. Cotangent is cosine over sine. So another scenario where we have a potential extraneous solution. Just an FYI. So then if we squeeze, we have 1 plus the cosine over sine. Ew.
Well, they'll just put us over the last. Just change the one side by side. Get rid of that one plus cosine.
Which what? 1 plus cosine? Well, the only difference is this time it's not set equal to 0.
But if you change the one side by side, that left side of the equation is subtracted.
Oh, I see what you're saying. So then, is that what you mean? And then set it equal to 0? Minus sine of x equals 0. Ugh.
Well, that's where we were last.
Yeah, except for now we have adding and subtracting. The last equation they were multiplied, so we can it's like technically factored. So if we could factor this, that would be good. But we can't, because it's not squared. Pull them apart? Negative sign? No, because it's not multiplying. Those are just adding. There's a lot of different ways you could add to 0. So, let's see, what could we do? Is there a way we can use a Pythagorean identity somehow? Immediately, if we went back to the original and squared, let's try that. I'm gonna erase everything. See if this will work. Square it. Square it. So you get cosecant squared plus 2 cosecant cotangents plus cotangent squared. So what's a Pythagorean identity there? Cotangent plus 1. Ooh, interesting. I see it now. I'm going to set this equal to 0. So I'm going to subtract the 1 over. So now I have 2 cotangents squared. I have 2 cosecant cotangents. And the 1's cancel out. So now I can pull a greatest common factor. What's my greatest common factor? Yeah, 2 cotangent. I'm going to pull a 2. I don't know why. I feel like I should. So now I would have cotangent plus cosecant. Till Friday. So we got 2 cotangents of x equal to 0. Ew. This is still not nice. Sine over cosine. Sine. Well, this will still work. So you get cotangent of x equaling 0. So that's the y has to be 0. So where is the y 0? 2 pi again. This one is going to be cosine over sine. 1 over sine. Plus 1 over sine of x. Equals 0. Cosine of x equals negative 1. So where is the x negative 1? Pi. And then you have to think about what makes that 0. So sine the y is 0 at pi over 2, right? Pi. The y, the sine is y, so y is 0 at. Oh, I think 2 pi. Because the y, not the x. It's the y. The y is 0 at 2 pi. Oh, I see what you're saying, and 0. Oh, so good, it's a no solution? Wait. What is the answer? 24? They say it's... They said the answer is pi over 2.
Yeah, I thought you were saying that. You were saying that y is 0 pi over 2.
Y is 0. No, it's y is 0.
Sine 0.
Yeah.
Is y over r. So we're looking for value of y 0. And that's at 2 pi.
The y is at 2 pi, right. Yeah. So wait, cotangent is x over y, so where the x is 0. Oh, I see what I screwed up. I screwed this answer up. This should be pi over 2, because cotangent is x over y. So the x is 0. The x is 0 at pi over 2, right? And this is extraneous. Pi. So yeah, you're right, Ansel. Oh my gosh. Woo. So we should probably do some... No, it was right. I just screwed up one answer. So it's just this one.
No, all that work is kind of be like